Hi, everyone. I'm Ashley McManus, Senior Director of Global Marketing at SmartEye. Welcome to the Human-Centric AI podcast, where each episode we feature thought leaders doing cutting-edge work in the AI space. A little bit about us. SmartEye is the global leader in human insight AI, technology that understands, supports, and predicts human behavior in complex environments, bridging the gap between humans and machines for a safe and sustainable future. Today's episode features prior guest, Dr. Pernilla Bulot, product specialist at iMotions, where she consults and trains researchers on multimodal biometric data collection and study design. Penny speaks with Dr. Ryan Jane Jacoby, who is a licensed clinical psychologist at the Center for OCD and Related Disorders at Massachusetts General Hospital and an assistant professor of psychiatry at Harvard Medical School. Her clinical and research interests focus on the behavioral and psychophysiological measurement of transdiagnostic psychological processes using multi-method approaches. From investigations into clinical mental illness regarding bipolar disorder, depression, and PTSD to general health monitoring, education, and performance, multimodal biosensor studies have seen blossoming interest. These two experts covered how combining facial expression analysis, heart rate, eye tracking, skin conductance, and other multi-sensor behavioral research technologies can have immediate implications on the clinical, diagnostic, or intervention aspects of mental health research. Let's listen in to learn more.
Hello, everyone. Good morning, good afternoon, wherever you are in the world. Thank you so much for joining this co-webinar presented by iMotions, SmartEye, and Affectiva. Today, we are dwelling on mental health and measuring and diagnosing mental health using biosensors. We're going to get into everything about what that means. We have two amazing researchers here, Dr. Pernilla Bulot and Dr. Ryan Jacoby, who are going to tell us all about their thoughts and research on the subject. So we're going to get right ahead, but let's introduce our researchers today. So we have Dr. Ryan Jacoby here. She's a clinical psychologist at the Center for OCD and Related Disorders at Mass General Hospital, and she's also an assistant professor of psychology and psychiatry at Harvard Medical School. She's been an iMotions client for a long time and is doing some very interesting research that I don't want to spoil, so I'll let you introduce yourself a little bit more. And then we have Pernilla Bulot, PhD, also working in neuroscience and has been a product specialist at iMotions for a few years now. So I'm going to turn my camera off and let the two of them take it away. And if there are any questions, I will be back. Thanks so much.
So yes, as was mentioned, I'm Ryan Jacoby, and I believe I've been an iMotions client since 2017. So I think MGH was relatively early in adopting the system. Actually, when I joined, we'd already had the equipment, but no one was currently using it. So I sort of led the charge in our lab for getting the equipment up and running, and I've been using it in studies ever since. And a lot of my research is on OCD, understandably from my position, but also, as I'll be talking about today, I've been increasingly interested in transdiagnostic constructs and how can we measure those in the laboratory to expand upon our self-report measures. So yeah, I'm excited to speak to you all today.
Yeah, thank you, Dr. Jacoby. Hey, everybody. My name is Pernilla. I also go by Penny, which you already know me. You may only know me by that name. So I'm a product specialist at iMotions, as Kate mentioned, which basically means that I function as a consultant. I talk to people that are doing biosensor research at various levels, and I help them figure out what is the perfect hardware for them, the perfect study design for them, all that good stuff that's a part of thinking in long-term perspective about your research. I'm also a tech expert, which means that in my day-to-day life, I spend a lot of time testing out new pieces of hardware, anything from voice analysis to new EEG devices, figuring out if they live up to the scientific standards that we go by, and also to expand our ability to constantly have a greater multimodal platform here at iMotions. Before coming to iMotions a bit over a year ago, I was a postdoc at MGH and Harvard Medical School, where Dr. Jacoby currently is. And before that, I did my PhD at Emory University. And throughout my entire scientific career, I've been focusing on brain development and also been really, really interested in understanding the factors that influence how we become who we are. If you're noticing that I have an accent, it's because I'm from Denmark. So yes, if you can't understand something, please just put it in the chat, but I seem to be legible generally. All right. So I'm going to run the show for a little bit first, where we're first going to go into a little introduction about why are we even talking about biosensors in mental health. I'm going to zoom in on some concrete examples of research that's been done with biosensors in clinical mental illness research. And then I'm going to leave it over to Dr. Jacoby, where she's going to give an introduction to how she's been using biosensors in her research. And at this point, we'll be starting to have a bunch of different questions. I'll be asking a lot of questions. And of course, we'll also be talking about what the future looks like when using biosensors in mental health and illness research. All right. So the first thing I think is really important to do is trying to get an understanding of what is mental health and what is mental illness. So generally, when we talk about mental health, we're talking about a state of mind that's characterized by emotional well-being, being good at adjusting to new situations. It also means recovering pretty fast from stressful situations. People with good mental health are typically good at creating new relationships and maintaining those relationships in a healthy and constructive way. In contrast, people with mental illness tend to not be so great at all of those things. Now, mental illness is a really, really vague term to refer to a lot of different types of people. So mental illness refers to people that are struggling with depression, schizophrenia, bipolar disorder, things that can be super duper different. But generally, these different types of conditions are always characterized by cognitive and emotional disturbances, abnormal behaviors, and impaired functioning. And so that impaired functioning could, for example, be not being able to attend for a long time to certain stimuli or things that are happening at work. It could be not being so good at creating and maintaining relationships. Now, a big part of my own work and a lot of people's research out there has been trying to figure out what is determining our mental health. And so a lot of research has nailed in that the environment that we grow up in and that we currently live in can really influence our mental state. So if you have traumatic childhood memories, or you're currently living in an abusive household, you're much more likely to struggle with a mental illness. But this can also be work environment or school environment, such as being bullied or socially isolated. There are other types of physiological markers too that can really influence whether or not you struggle with mental illness. So this could be, for example, genetics. There are certain genes that will make you more or less vulnerable to mental illness. And then something I find really interesting is how chronic illness can actually make us more vulnerable to struggle with mental illness. And likewise, people with mental illness are more likely to struggle with chronic illnesses. So there's a lot of bidirectional relationships that are going on here. And it's really, really difficult to figure out what's actually the root cause of a mental illness. Now, if we put the cause aside and we focus on how we can use, how do we actually treat mental illnesses and how do we assess mental health, why do we even want to talk about biosensors? Well, the reason is that the traditional approaches don't really seem to work. So the traditional approaches that are currently also being used are things like surveys and clinical interviews that are based on the Diagnostic and Statistical Manual of Mental Disorders, also referred to as the DSM. There are various different types of versions out there. Right now, it's the DSM-5. The DSM and other types of illness categorization manuals are based on illness categories. They're seeing depression distinct from schizophrenia, distinct from bipolar disorders, and oftentimes the only way of evaluating people is based on surveys. Now, over the last decade or so, there's been much more of a push towards thinking about symptoms as a spectrum. So people are less about being in a category of illness and more about being on different types of spectrums that sometimes overlap in different ways. Some of the work that has been motivating this push has been technology, including biosensors, that have now enabled us to figure out reliable biomarkers of what is a certain mental illness or what is a certain symptom. How can we reliably and quantifiably measure that without only relying on what people are saying? Now, of course, surveys are always important. We always want to honor and listen to what it is people are explaining about their own lived experience, but that's not always something they can articulate that well. And that leads me into this slide, which we talk about a lot in iMotions whenever we try to pitch why biosensors are important. But it's based on research. It's based on decades long, centuries of research, where we know that the conscious behavior that people have access to, that we know what's happening in our bodies or in our minds right now, or for example, what happened yesterday, that's limited as to how much we can actually remember. And so the traditional research methods are quite limited as to how much they can learn, because we're not always capable of telling everything that's happening. And so that's where we start talking about non-conscious or subconscious behaviors. And that's where biosensors can really capture a lot. They can capture where your eyes are moving on the screen when you're seeing something, how you're reacting in a brief second to something that you're seeing, and you might not even realize that that's going on. And it's those types of subtle biomarkers that can now actually start informing how we think about mental illness. So there are a lot of different types of biosensors that are being used in mental health and illness research, and they vary. We won't be able to talk about all of them. It sounds like you guys are already making up a very heterogeneous group, which is awesome. Some of the biosensors that are often being used are things like EEG. That's a more advanced type of biosensor. It requires more labor. It requires more money. It can give you brain activity readouts when people are experiencing something, and that's all by putting all these different sensors on the top of your skull. But then you also have biosensors that are much less invasive, things like eye tracking or facial expression, where you can sit and look at a screen or look around in the environment, and then a sensor can actually track what are you looking at and how is your face expressing your responses to it. But it could also be things like your phone, where how much are you using social media? How much are you texting with friends? And your voice, if we can literally just have a microphone, which is on most of the smart devices out there today, then we can analyze the voice, the tone of voice that you're using, or even the language you're using as well. And that can all feed into our understanding of mental illness. So what are researchers currently doing with biosensor data? There are a bunch of different ways that you can approach it. This is the way that I think about it, and that we're going to be thinking about it throughout this the rest of the conversation today. So biosensors are being used to identify new correlations. So this is really biomarker research. Is there something where we can say when they look in a certain way, when they behave in a certain way, that is something that's associated with a certain mental illness? And that leads into a second category, which is the detection. So can we use biosensors to detect whether or not a person has a mental illness? This is not really being used too much today, unfortunately, but it's definitely a path we're walking towards. It's being used and studied much more in the fields of neurodegeneration and brain development. And so I'm very hopeful that we'll be going in that direction with mental illness research as well. What I'm super duper excited about personally is the ability of using biosensors to predict onsets of different types of disease states. So that could be changes in mental states, for example, from going to mania to depression and back again, or maybe suicidal behavior. And so that is a huge untapped potential that biosensors are currently starting to tap into. And then the last big category is how biosensors are being used to evaluate new types of interventions and figure out, are there particular subgroups of patients that might benefit from one intervention over another without just relying on surveys, but actually having objective quantifiable metrics to rely on. And so if you followed us for the last 6 months or so, you know that I have, together with my coworkers, been leading what we now call a mental health campaign, where we've really been diving very broadly into how biosensors are being used in mental health research. And so we have some podcasts that are out there where myself and other colleagues and other researchers are talking about how biosensors are being used to address mental health and illness in education and performance, for example, in the school system, how it's being used in brain development research, for example, in the field of autism. And I'll also soon be coming out with a blog that's assessing how biosensors are being used in the work environment. We have clients that are doing that here at iMotions, and that's something we're super excited about. But for today, we'll be diving into clinical mental illness and learn more about how biosensors are being used in that regard. And so I'll just give some concrete examples of how research has been using biosensors to address whether we can characterize or diagnose particular types of mental illnesses based on the metrics that we get from a biosensor. I'll be giving some concrete examples about how biosensors can predict the changes in mental state. And I'll also give an example specifically on how biosensors can be used to address interventions. And fear not, Dr. Jacoby will give examples on all of this in her own research as well. This is just to set the stage and give you a more varied understanding of all the ways that it is currently being used. So the first one, which I'm quite excited about, well, I'm quite excited about everything, as you probably can tell, but something that I'm quite excited about is the ability to literally just monitor people's movements. And so that can be recorded with devices that are referred to as actigraphs. They are being found in wristbands, in your smartwatches. It's even something you can monitor on your phone. And it basically just gives you a readout of how people are moving around in the environment. And what's really, really cool and so basic is that we can tell based on actigraphy data whether or not people fall into a patient category or not. And so in people with depression and schizophrenia, there is a significant reduction in motor movements in general, and there is increased stereotypical behaviors in schizophrenia. So this is something that's so simple and might be very intuitive to you that, well, obviously that there are changes in how people behave, but imagine that we can now start, when people think that they're coming into being screened from depression, we can start giving them these different biosensors and say, hey, come back in a week and we'll get your metrics. And then we can supplement that with what you're telling me here in this clinical interview. Bipolar disorder has been quite well studied with biosensors, which is exciting. What people have found there is that during the manic phase of bipolar, there's a huge amount of changes in a person's autonomic nervous system. So that's things like heart rate variability, heart rate beat to beat. And all of that can be measured more invasively, as you see here, with electrodes that are specifically sitting on your chest, for example, or it could be based on, your smartwatch, again, that can measure heart rate. Now, one thing you do want to be mindful of is that not all of the technologies are equally accurate at measuring these different types of biometrics. And that's basically what I spend a lot of my time talking to people about, what is the best device to get the type of data that you want. And then the last example is is using a device that can capture galvanic skin response, also referred to as electrodermal activity. And so electrodermal activity or galvanic skin response can measure the changes in the sweat that's being released from, for example, your palms, but also other places on your body. And that particular type of sweat that's being released is very specific to being aroused. So it's not necessarily about temperature, but rather whether or not you're in a very excited state or in a very stress state. And what researchers have found is that people that are struggling with depression or suicidal behaviors like ideation, they tend to have a general hypoactivity, so reduced arousal levels. And again, this feeds into the ability to characterize what does it mean to struggle with these different types of illnesses, and is this something that we can use to better improve the way that we diagnose people? Then, of course, as I mentioned, one of my favorite parts is understanding how we can use this biometric data to predict changes or onsets of mental illness. Could we use, for example, galvanic skin response and actigraphy to predict whether or not people are about to have an onset of depression or have changes in schizophrenia states or having changes in suicidal ideation that might lead to actual suicide attempts? This is all something that people are trying to really figure out, and something that a lot of researchers are pushing forward to. One of the concrete examples I want to give you about prediction research with biosensors is based on bipolar disorder research. And so instead of using sensors that are looking at heart rate, these different papers look specifically at the types of metrics that they could get out of only just using a phone. So they use self-reported mood, texting behavior with friends and whoever they were texting with, step count, so kind of similar to actigraphy, and voice analysis. And by combining all of these different metrics that they literally could just get out of a phone, they could predict up to 90% accuracy whether people were changing in their mental state. So going into a manic state or going into a depressed state. And so that's telling you something where now we can start using these types of data to communicate with your doctors or your therapists and give them warning signs as to, hey, we might need some extra intervention at this point, and we can actually help people not go into as severe disease states as they might have been. Another example of how biosensors can be used for predicting mental illness is in the context of post-traumatic stress disorder. So around 10 to 20% of people that experience a trauma develop PTSD, which stands for post-traumatic stress disorder. But a huge challenge is figuring out who those people are. And so there are some researchers that have been using this galvanic skin response device, as I mentioned earlier, to actually predict who will develop PTSD. And this study, which is one of my favorites, frankly, did something that was so basic and so simple to implement, which was that they took people that came into the emergency room after a traumatic event, and they measured their galvanic skin response. They measured it, and then they followed up with them on a monthly basis for 6 months to track what their trauma severity symptoms were. What they found was that they could put people into 3 categories, one of them being the most interesting. So they found people that had just really low level of trauma symptoms in general, and that didn't really require much therapy after. Those people correlated with having the lowest skin conductance responses, which is the galvanic skin response, upon coming into the emergency room to begin with. Then there were another group of people that had a higher level of trauma symptoms, but recovered quite quickly with standard treatment back to more healthy trauma symptom levels. And those people came in with a slightly non-significant higher skin conductance response. But what really, set this study apart was that they found that there was this group of people that had a significantly higher trauma response. And it was resistant to treatment in general. And they also showed a much, much higher skin conductance response that was significantly higher from both groups. So now you can imagine a situation where when people come in after a traumatic event to the ER or really anywhere else, you can measure their skin conductance response with one of these devices that are very simple. You put them on your hand, you get data for 5 minutes, and then you can actually start predicting what type of intervention do they need? Do they need more comprehensive treatment? Do we need to check up with them more? And these are the types of things that biosensors give us the opportunity to do. And so that leads me into the last category of research I want to talk about before I pass it on to Dr. Jacoby, which is talking about biosensors to address interventions. And so we're going to stick to the topic of PTSD. And now we're going to focus on, well, when you do have PTSD, how do you then treat it? And that is something that there are a lot of different methods out there, but there are still a lot of people that are treatment resistant. And so there is a huge push towards figuring out how do we address what those people need. And something that is coming up more and more with the advancement in technology is using virtual reality, which is acronymed by VR. And virtual reality, if you're not familiar with it, is basically where you put this headset on and then you can be in a totally different type of environment. It's like being inside of a movie. You can walk around in it, you can act in it. It's very immersive. And so what researchers have started doing is that they've been using a personalization of the VR environments, where they sit down with a patient and they say, so tell me about what happened to you. In these cases, it was all people with military sexual trauma. And they told them, this is the scenario, and they reinvented the scenario in the VR environment with various therapeutic strategies. And then they could look at what are the long-term effects of this type of very immersive type of treatment. And what they found there was that not only was there over a course of 6 weeks a reduction in clinical PTSD and depression symptoms, but they also found reduction in heart rate. So autonomic dysregulation is something that's quite prevalent among people with PTSD and other types of anxiety disorders. And this was just one of the many metrics they could have measured to establish, okay, this intervention really did something physiologically, not just mentally. And so this is now we're starting to establish novel types of treatments with quantifiable metrics. So I've given you a little rundown of various studies that are out there. And one of the missing pieces that I identified is many of the studies, most, if not all, are using one biosensor at a time. And this is a challenge because one biosensor will give you one perspective. It's not going to give you the entire truth. No biosensor will ever do that. No person will ever do that either. And really, this is pushing forth this idea and sentiment that we really should be focusing more on combining sensors to create stronger insights. So we want to use many different sensors to holistically get an understanding of what's happening inside of a person's body, not just with their heart rate, not just with their skin response, not just in their brain, but all of it together, so we can actually start increasing the accuracy of our prediction, of our diagnosis, of our intervention assessments. So thankfully, we do have researchers that are doing that. And one of those researchers is Dr. Jacoby, who introduced herself earlier. I'll just give you a reminder. So Dr. Jacoby is a clinical psychologist and assistant professor at MGH and Harvard Medical School. And her work really centers around repetitive negative thinking. She uses a variety of different biosensors, including facial expression analysis, galvanic skin response, screen-based eye tracking, and heart rate. And so I'll let Dr. Jacoby take over now, give an introduction to her research.
Yeah, so thank you so much for that great introduction and overview. So I'm really excited to be here to just tell you a little bit about how I've been using the iMotion system in some studies that we recently completed, give you a sense of kind of how things are looking as we're starting to analyze our data. So first, to provide a little bit of context for the research that I've been doing. So the idea for the study that I'm going to be talking about actually came out in grad school. So I have a PhD in clinical psychology. So I'm a clinical psychologist. And when I was working on my dissertation, we were recruiting for individuals with OCD, which is my area of expertise. And so our ads were advertising for individuals with unwanted intrusive thoughts. So we wanted to capture people who maybe had a diagnosis of OCD, as well as those who maybe didn't, and who just kind of identified with this idea of having unwanted, intrusive, obsessive thoughts. So we were finding in our advertisements, though, that yes, we were getting people calling in with OCD, but we were also getting individuals calling in who had unwanted repetitive thoughts about their future and worries, or having unwanted repetitive thoughts about how depressed or down they were feeling, or perhaps about eating and food and weight and shape, or even traumatic memories that kept coming back. And this experience of recruiting for this one study on OCD really got me starting to think about what are maybe some of the similarities and differences across of different types of repetitive negative thinking or intrusive thoughts beyond just OCD, which is the disorder I had been previously studying. And a reason why I think this question is really important, so we've already been talking about the DSM-5. That's kind of our typical way that we will diagnose mental health conditions in a clinical setting. So trying to figure out, does someone meet diagnostic criteria for obsessive compulsive disorder, or is this major depressive disorder? And using our criteria to kind of break people into groups and into categories. And then based on those categories, as a therapist, we then will pull a manual off the shelf, treatment manual that will tell us how to treat OCD or how to treat depression, and we'll sort of walk patients through that manual. And so we, as it relates to repetitive thinking, we also think about these repetitive thoughts typically in separate categories. So to give some examples, someone with OCD might have unwanted repetitive thoughts about, is this clean enough? Or did I lock the front door when I left the house? Someone with generalized anxiety disorder, or abbreviated as GAD, might have unwanted repetitive thoughts about the future, about worries, like, am I going to lose my job in this economy? Things like that. Someone with major depressive disorder or MDD might have unwanted repetitive ruminations about the past, like maybe past perceived failures, like a relationship that ended. What's wrong with me? Am I unlovable? Am I going to be alone forever? Things like that. And we sort of conceptualize these as being separate problems. But I can say just clinically, we often see these same types of thought patterns, these same diagnoses that we would use the DSM-5 to categorize in the same person. And so when in research of mental health, we'll refer to that as comorbidity or co-occurring disorders among the same person. And we know that there are high comorbidity rates as high as 40 to 80%, where if you have one of these conditions, you're very likely to have another one. And so this begs the question of, are we really measuring these things in the best way if so many people meet criteria for more than one, and so many patients report repetitive thoughts in more than one category? So this really led me to have this question about what are maybe some of the transdiagnostic processes that cut across these various conditions that might be more fruitful for studying rather than studying each in isolation. So this then led me to the research that had already been done and was already occurring on repetitive negative thinking. Previously, though, a lot of this research had mostly focused on depression and anxiety, and OCD hadn't so much been a part of the picture. So that was sort of what I was really thinking about is, maybe OCD is another form of repetitive thinking that we could consider in studying these problems. And so what really struck me in reading this literature is that even though the thought content among these three presenting problems is very different, OCD, generalized anxiety, and depression, with those examples I gave before. Of course, losing one's job is very different from being afraid that you're going to fall sick. The types of processes that individuals with repetitive thinking are going through in their mind are actually very similar. So the content's different, but the process is similar. So in particular, these types of thoughts are perceived to be very repetitive, very persistent. Patients will primarily describe them as being difficult to control, difficult to disengage from. They report being very stuck on these thoughts, and they result in a lot of distress and interference for patients with these conditions. And so it was starting to seem like there might be more similarities than differences in terms of the thought processes among these different thoughts. However, a lot of research that had been done on repetitive thinking previously was using surveys, using paper and pencil questionnaires, asking people to describe their thoughts. And I don't know about you, but I have a really hard time thinking about how am I thinking about my thoughts? It's very kind of metacognition is hard for people to really wrap their minds around. People are able to sometimes tell you what they're thinking in terms of the content, but the process is really hard for people to comment on. And I think this relates to things that Dr. Abiola was talking about earlier in terms of self-report measure is certainly a part of the picture. And of course, we want to ask patients what they're thinking, how they're feeling, but sometimes people aren't able to be in touch with those processes moment to moment in real time. Before I get into a little bit about the current study, just a little bit more about why repetitive negative thinking is important. So we believe that repetitive negative thinking is a vulnerability factor for anxiety and depression. So a lot of folks will start off having these unwanted intrusive thoughts and then later develop an anxiety or depressive disorder. It also is a maintenance factor in these conditions. So going over the same problem over and over again in your mind keeps that stressor active, keeps you feeling anxious, keeps you feeling depressed, and sort of maintains the cycle in a way that we don't want. And we also know that repetitive thinking undermines treatment. So people who engage in this type of thinking, they're not able to get as much out of therapy that often is trying to help them learn something new. So by approaching things that they're afraid of in the course of therapy, or if they've been withdrawing in their home because they're depressed, helping them get back out into their environment. And it's tough if you're stuck in your head, you're not really out in the world, you're not really taking in lessons from the things around you. And it's really hard to get as much out of treatment if you're stuck in your mind. But existing treatments have been unable to optimally target repetitive thinking. It's a common residual symptom following even successful treatment. So for example, people with depression might say that their mood is better, they're not feeling as sad, not feeling as depressed, but they still have ruminative thoughts that they struggle with. And so based on this, even though the study I'm talking about today isn't a treatment study, a question I'm always asking in my research is how can we better improve treatments for patients with anxiety, depression, and OCD? And so if we can better understand the factors that underline repetitive negative thinking that cut across these different conditions, we can help a large percentage of patients in terms of being able to better address this problem in treatment and prevent people from being more likely to relapse following even a successful course of treatment. So this led me then to the current study where I really wanted to better understand, based on that, recruiting in grad school and seeing that there are some similarities and differences across repetitive negative thinking. I really wanted to understand maybe what are some of these similarities and differences that we could better understand and use the iMotion system to be able to tap into a variety of different psychophysiological processes in addition to just self-report. So first off, I hypothesized that there might be one core process that cuts across these various conditions, and that process is attentional control, which is essentially the degree to which people feel as though they're able to shift and sustain their attention, even in the presence of distractors. So kind of goal-oriented activities, being distracted by other things going on in one's mind and kind of getting off track. And the reason I had this hypothesis was just from talking to these patients. And the number one thing that patients will say is that they really have trouble stopping these unwanted thoughts, disengaging from them and putting their attention where they want it, which is generally, on their work or in social interactions that they're having, and just being really stuck in their mind. And where the biosensors come into play is with eye tracking. So we can actually use a behaviorally quantifiable metric, and I'll speak more about specifically how we use the eye tracker in a little bit, in order to tap into potentially this mechanism of attentional control. The other reason why attentional control is compelling is it can be a malleable treatment target, something that we can directly target in therapy, helping patients learn to better control their attention. So I'll speak about that a little bit at the end, using interventions like mindfulness, which specifically tap into helping patients with attention. But then I also thought that there might be some differences. So while all patients might struggle with attentional control and they might have difficulties disengaging their attention specifically, the literature has been a little bit more mixed in terms of things like autonomic arousal across these different presentations. So some studies suggest that if you're stuck in repetitive thinking, they'll bring people into the lab and have them ruminate about a topic or worry about a topic and try to measure things like their skin conductance and their heart rate. Some studies find that your heart rate and skin conductance will elevate when you're thinking about these things. But other studies find the opposite, which seems kind of counterintuitive. You would think like if you're worrying, you're going to get more activated. But there are some theories that suggest that these cognitive processes are trying to actually tap down emotion. And so patients are using it. The reason that they're worrying or they're ruminating is they're trying to control their emotions. And so it is a short-term, long-term trade-off where it might work in the short term while you're trying to mull something over, but of course in the long run it's prolonging your distress. But again, mixed findings in the literature that I wanted to better understand, and most studies had only studied one type of repetitive thinking in isolation, maybe using only one sensor, and so I wanted to include all sensors and all patient presentations in the same study. And to my knowledge, there hadn't been any studies using facial expression analysis in this type of research. So I also had questions about the emotional valence of these types of thoughts. So I'll speak a little bit about my methods in a minute, but trying to understand when people are actually engaging in repetitive thinking, for example, someone with anxiety, are they feeling more fear, showing more fear-based emotions on their face when they're thinking about these things versus maybe depression might see more sadness in facial expression. So to summarize, we had two aims. One was to see if individuals with all these types of repetitive thinking had difficulty disengaging their attention from negative emotional stimuli, so impaired attentional control. And then also what are the differences in terms of physiological and self-report when folks are in the presence of their repetitive thinking across these three different presentations: obsessions, worries, and ruminations. We collected our data at the clinic at Mass General and the Center for OCD and Related Disorders. And as I mentioned, we use a number of different sensors I'll be talking about. And our sample was 45 individuals with elevated repetitive negative thinking identified on a questionnaire, and then 15 non-psychiatric controls who were on the very low end of that questionnaire and also didn't have any other psychiatric diagnoses. All right, so these are just some sample items from the questionnaire that we used. It's longer than this, but just to show you a couple sample items, this is sort of the gold standard measure for capturing repetitive negative thinking using paper and pencil questionnaires. So the best that we sort of had going into this research. So it's questions like the same thoughts keep going through my mind again and again, or I can't do anything else when thinking about my problems. So it really tries to tap into the process of thoughts without getting into the content, which of course can be very varied person to person, and getting a sense of how much are these thoughts interfering, distressing, repetitive, persistent, things like that. So we use that, of course, in the study to capture people's self-report kind of trait levels of repetitive thinking. So not so much in the moment in the lab, which I'll talk about in a moment, but more so like in general, how much do you struggle with this in your day-to-day life? And then to measure attentional control, we used this task is called the attentional engagement disengagement task. And it's fairly complicated at the outset, but actually is a pretty cool task. So I'm really just going to focus on the trials. There are many different trials and iterations, but I'm going to focus on the ones that I think are the most interesting and relevant for our hypotheses. So it's always a blank screen, a central fixation cross, and then once participants look at the cross, the program will wait until they're looking at the screen. They'll then see two facial pairs on the screen. And so one is always a neutral face and one is always an emotional face, and they'll see it for 3 seconds. The emotional face could be happy, as you can see in these images, or it could be sad, disgusted, fearful, so a variety of different emotions. And so then the trials after that I think are the most interesting are on the bottom line, kind of taking it from there. which the computer will actually wait until participants look at the emotional face for a minimum of 100 milliseconds. And so it would wait for the fixation on the emotional face. And then once participants fixated on that face, a probe, either a square or circle, would appear around the neutral face. And it would wait for participants to look at the neutral face and measure the time to the first fixation. So that's the time in milliseconds it took participants to move their attention into the area of interest, into that neutral face, and disengage their attention from the emotional face. And participants on their end are just pushing a button if they see a square or a circle. So we're trying to keep them engaged. But really behind the scenes, it's that time to first fixation that we're interested in. And it's these disengagement trials that we find to be most interesting because it sort of stands to reason, and based on previous findings with this task, that if patients are having difficulty disengaging their attention from negative emotional stimuli in their mind, so for example, someone with depression who's really stuck and ruminating about something negative, we also find that those same patients have difficulty disengaging their attention from negative emotional stimuli in the form of faces on this task. So this task had previously been used with folks with depression, but in this study, we wanted to see, does this finding about difficulty disengaging from emotional stimuli generalized to other types of repetitive thinking like anxiety and OCD. And so then in addition, we had folks go through a scripted imagery paradigm. So everyone went through a neutral script that we wrote for them, and they recorded that had to do with, reading a book on a fall day and looking out the window at the leaves falling, relatively benign. And then each participant, both those with repetitive negative thinking at clinical levels, as well as our healthy controls, generated an individualized script that related to some unwanted intrusive thought that they could identify. So for patients, it was the one that was most bothersome. And even for healthy controls, I think everyone can come up with something that they're currently kind of stuck mentally on. So it wasn't hard for everyone to come up with something. So to give some examples of what these scripts might look like, so someone with OCD might write a script about, I walk into a dirty restroom and I see how gross everything is and my heart starts beating. And I think about, all the germs that could be on those surfaces and how I might get sick, et cetera, et cetera. And we would kind of help them flesh it all out and make it as descriptive and realistic as possible using all their senses and all that. Someone with generalized anxiety disorder might write about losing their job. Someone with depression might write about a relationship ending, and they got to choose the topic, whatever was most distressing for them. And we would make an audio clip of them reading that script into the audio recorder for them to listen to. And while they were listening to both scripts, we were collecting lots of data. So we were collecting their galvanic skin response or skin conductance, so the sweatiness of their palms. We were measuring their heart rate while they were listening to the scripts. And then we had them looking at the computer screen so we could measure their facial expressions as well as getting measures along the way of just self-report. So what is your current level of distress from 0 to 100 at various points throughout the task? So we're still cleaning and analyzing the data. There's a lot of data to analyze with all these sensors, but it's starting to look like there might be a bit of a trend that we're seeing. So I wanted to give you a little bit of a sneak peek, and who knows, maybe I'll be back at a future webinar to tell you exactly what we found. We haven't analyzed the attentional data yet, so no updates there. But in terms of the sensors, the biosensors and the script-driven imagery, we're starting to see something that actually is a finding that is coming out more and more in the literature, which is that there might be a disconnect between patients' self-report in terms of how much distress they're describing when they're listening to specifically their unwanted intrusive thought script compared to their psychophysiological measures. And as a side note, I think that that's something that often is talked about of like, oh, like our biosensors aren't good enough. They can't capture what we can capture with clinical interview and self-report. But I actually think that there's a more interesting story there, which is that when there is this disconnect, so in particular, we're finding that folks, the patient group who have repetitive negative thinking and they struggle with that, they're reporting similar levels in terms of they're not reporting, they're displaying similar levels in terms of their heart rate and their skin conductance to the healthy controls, where everyone, regardless of whether you're a patient or you're a healthy control, you're showing elevated skin conductance and heart rate when you're hearing an intrusive thought script relative to the neutral one. Everyone's heart rate goes up, skin conductance goes up when they're listening to something that is personal and distressing. And yet patients aren't. We were expecting an interaction effect where patients would be exponentially more distressed by this, which is something that we're not seeing. And yet their distress levels self-reported when they're kind of in the moment, we're asking them, how distressed are you right now listening to this script? They are showing that elevated distress. So again, this disconnect between what they're reporting, which is a lot of distress, versus their psychophysiological measures, which are elevated relative to neutral, but no more so than healthy controls. I think that this disconnect is really interesting in terms of how we might think about helping these patients who are reporting a lot of subjective distress above and beyond what the psychophys measures might tell us. So in particular,
no, I just I have one comment there, and I know we talked about it in the past too, Dr. Jacoby, but that I think this result really speaks to the fact that people that do struggle with mental illness, including repetitive negative thinking, tend to also have a lack of interoceptive awareness. So this inability to really tell what's going on in your body, or maybe even overestimating, that your heart rate is going faster than it really is. So they feel as if they think they're in a more distressed state, but physiologically, it's actually the same.
Yeah, exactly. Bring this all together a little bit about the implications based on this work. So first, if our hypotheses related to attentional control are supported, which we don't know yet since we're still analyzing the data, this could identify a transdiagnostic mechanism for individuals with repetitive negative thinking that we could try to target in treatment. So in particular, as I mentioned, mindfulness-based treatments really help patients trying to learn to shift their attention, to sustain their attention. And anecdotally, this is something that folks with this repetitive negative thinking, when I mention mindfulness, we're sort of doing a treatment study now with this population. Folks will often say, oh, I've tried mindfulness. It doesn't work for me. I just can't focus. These are, in fact, the exact patients who actually probably need mindfulness skills, being able to learn these skills. So that's definitely something that I'm interested in terms of future directions. And as well as, I've also been thinking about just this disconnect between folks with elevated subjective distress despite comparable psychophysiology to healthy controls, perhaps treatment techniques like distress tolerance, helping people tolerate their psychophysiological responding to different stressors and stimuli might be also a beneficial treatment target for these types of patients with that disconnect.
I have a few questions. In terms of the future of where the biosensors and mental illness research is going, and that's a really exciting topic. We are mentioning, Dr. Jacoby, the just-in-time therapy. Are there other types of technologies or avenues where you're seeing that, biosensor research is really going for mental illness research?
Yeah, I think that's the main one that I wanted to mention, because I do think that, especially, for example, in the field of suicidal thoughts and behaviors, I know that that's an area that folks are really interested in. How can we sort of predict who's going to make a suicide attempt and what are sort of the warning signs, whether it be kind of like voice analysis or folks who aren't, like I mentioned, not leaving their room, different kind of warning signs in terms of the psychophysiology. And what's really interesting about this work is if you can get a big enough data set, you don't even need to go in with any specific hypotheses. The data set will sort of generate sort of these risk factors for you and kind of spit them out and tell you, okay, this constellation of physiological and self-report markers is concerning. And then we can sort of ping that person and reach out and get them help in real time. I think that is incredibly exciting work that folks are doing.
Absolutely. I think that's, when people start actually using machine learning on biometric data sets, that is exciting. I'm not seeing too much of that. I see more machine learning being used for various demographic factors or surveys or things like that. But I think when we start pairing those two together, that's going to be super powerful.
Yes.
Well, thank you so much, everybody, for attending. We have a bunch of different resources on our website. If you follow us on LinkedIn, you'll also have seen that iMotion, Smart Eye, Effectiva, and myself have all been posting a lot about all this. So I encourage you to do that.
Great. Thank you so much for your time, Dr. Jacoby and Dr. Puto. We really enjoy it. And please email us at marketing@imotions.com, and we're happy to connect you with both of our researchers. So thank you so much. Have a great rest of your day.
Thank you.
Thank you.
Bye.
One of the highlights for me from this conversation was how we need to combine these different types of multimodal sensors, from eye trackers to facial expression analysis, to create stronger insights, as that seems to be a missing piece in mental health research today. Then looking how real-life mental health researchers like Dr. Jacoby are applying these sensors to better understand and thus ultimately improve our treatment of these mental health illnesses makes me really optimistic for the future. I hope you enjoyed today's episode. Don't forget to subscribe to the Human Centric AI podcast on iTunes, Google Play, Stitcher, or wherever you get your podcasts for new episodes. We're also on social media, so please reach out to us on Twitter, Facebook, LinkedIn, and Instagram to share any feedback you have on the show and weigh in on the discussion using hashtag Human Centric AI podcast. Don't forget to rate us and comment with your feedback to help make the podcast more discoverable for others. Until next time, thanks for listening.